Let us continue our last session. But before starting, let us revisit fast, just in a minute, that what we have seen so far. We have given the region in rectangular form from x is equal to a to x is equal to b and y is equal to c to y is equal to d. Then how we are writing the limit is this. In place of the rectangular region, suppose we have given any general region R, then how we are writing the limits for the case dy dx and for the case dx dy is this. And for this particular example, x equal to 0, y equal to 0 and x plus y equal to 1, our region is bounded by these three lines. Then how do we write the limits of the integral for dy dx case and for dx dy case? Now let us go ahead. For the next example. Our region R is bounded by the curve y is equal to say 3x and y is equal to x square. The region is bounded by these two curves. What is our first task? Our first task is always to find the region, to understand the region. Without understanding the region, it is not possible to write the limits. Okay, so let us draw the region first. Y say this is x-axis, origin, the curve y is equal to x square. How we are drawing y is equal to x square? So is the curve this is the curve y is equal to x square. Then the line y is equal to 3x. So the line y is equal to 3x passing from 2 points. One is when x is equal to 0. So say y is equal to 3x. When x is equal to 0, what we have? Y is equal to 0. So it is passing from one point, that is origin, and this is origin 0 0. Then another one is, should we go for the intersection point of these two curves? Y is equal to x square and y is equal to 3x. So what we have? X square is equal to 3x, which gives us x square minus 3x equal to 0. And so we have x into x minus 3 equal to 0, which gives us two values of x. X is equal to 0 and x is equal to 3. Right. So when x is equal to 0, what do we have? Since y is equal to 3x, y is equal to 0. So this is the first intersection point, 0 0. In this case, when x is equal to 3, y is equal to 3x. So this is 3 into 3 is 9. So when x is equal to 3, y goes to 9. So the line is passing from these 2 points. One point is the origin 0 0 and another one is when x is equal to 3, y is equal to 9. So approximately suppose this is 3, then say this is 9. So this point is say x is equal to 3 and y is equal to 9. So the line is passing from these 2 points. the line y is equal to 3x. This is the equation of the line y equal to 3x, and this is the curve y is equal to x square. You know this thing. What is the region here? The region is bounded by these two curves. So the bounded by portion by these two curves is this. So my region R is this. Now once the region R is clear, we are able to write the limits. So let us start the procedure to write the limits. Whenever we are writing the limit, we are always having two cases with respect to dy dx and with respect to dx dy. So first of all, double integration fxy dy dx. For this case, what is our y, which is inner limit? What is our x is the outer limit, right? Next, double integration f of xy dx dy. X is the inner limit and y is the outer limit. But first, let us start the case dy dx. How do we write for dy? We write y, right? So we have to draw vertical line. How do we draw the vertical line? From bottom to upward direction. So let us draw the vertical line. Then when I draw the vertical line, I am entering in the region from the curve y is equal to x square. So y is equal to x square is my entry here. Y equal to x square is my entry. Now we moving towards inside the region, and then we go outside. So we exit from the curve which is line. Which line it is? Y equal to 3x. So our journey started from y equal to x square and will be ended at y equal to 3x, right? So the starting is the lower limit and end is the upper limit. So how do I write the limit? Y is equal to x square to y is equal to 3x. Now x, which is outer limit, always constant. So what we have to observe? How much portion of the x-axis is covered by the region. So if you observe, just take the span. So what you have to do? Just take the projection from the upside on the x-axis. Then you will observe that this much portion, see, this is the portion is covered by the region. So in this portion, the starting value is x equal to 0 and this is x equal to 3. So the left hand side point will be the lower limit, right hand side point will be the upper limit. So this point x equal to 0 will be my lower limit and this will be my upper limit. So which is x is equal to 0 to x is equal to 3. This is how do we write the limit for dy dx case. Now for dx dy case, what we have to do? Inner limit of x. How do we write x? In this way. So we have to draw the horizontal line from left side to right side. Clear? Okay, so let us write the limit for x. We are moving towards the region and we are entering to the region from this curve, and this curve is nothing but the line y is equal to 3x. Keep in mind, we always write first the equation of the curve. We don't worry what is the value of x, what is the value of y. We first choose which equation is for the entry and which equation is for the exit. That's it. Then we move forward to the right hand side and we exit from this curve. Which curve it is? We exit from the curve y is equal to x square. So in this case, our entry is the curve y equal to 3x, exit it y is equal to x square. What I have to write? Entry will be the lower limit, right? Which I have to write for x. X is equal to. So what is x here? X is equal to y upon 3. What is x here for the exit? Y equal to x square. So x is equal to actually plus or minus under root y. But our region lies in the first quadrant. You may observe. See, the region lies in the first quadrant. And in the first quadrant, y is positive, x is also positive. See, x is positive, y is also positive. Right. So we choose the positive entry. X is equal to under root y. So now, what is the situation here? The entry is the curve x is equal to y upon 3 and exit, which is the upper limit, x is equal to under root y. Right. Now, y. What we have to observe? How much portion of the y-axis is covered by the region? So I observe y-axis. So this much portion of the y-axis. See, this is the portion of the y-axis is covered by the region. So here the value of y is 0 and the top point is y equal to 9 and the lower value is y equal to 0. So the lower value is my lower limit y equal to 0 and the top point of the region becomes my upper limit, which is y equal to 9. So is this clear? Whenever we have given the curve y is equal to 3x to y is equal to x square, then how we are writing the limit? Let us understand one more little bit difficult example. Suppose we have given region R, which is bounded by y is equal to x square and say x is equal to y square. This is one of the standard example to understand the limits. What is always the first task? Draw the region. So this is x, y, origin. Let us draw the curve y equal to x square first. So say this is the curve y is equal to x square. Now let us draw the curve x equal to y square. So x equal to y square says this curve x equal to y square. What we need to identify? The bounded portion of these two curves, which is this. So here the region R is clear, but we need to identify the intersection points. Which two intersection point? This point and this point. One point is also clear, which is origin. So let us try to find out the another point. What we do? We have given two curves, y is equal to x square. Another curve is x equal to y square. So we compare these two equations. You may remove any one, either x or y. Let us substitute x equal to y square into this equation. Right. So what we have? X is equal to y square all square. That is nothing but y is equal to y raised to 4. So y raised to 4 minus y equal to 0. I take y common. So we have y cube minus 1 equal to 0. So what we have? Either y is 0 or y cube minus 1 equal to 0. Which are the factors of y cube minus 1? Y minus 1 into y square plus y plus 1 equal to 0. As you know, the equation y square plus y plus 1 has complex roots. Y square plus y plus 1 equal to 0 has complex roots. Do you know how to find the roots of this equation? How do you find the root? Compare this equation with ay square plus by plus c equal to 0, right? So let me explain just here. Y square plus y plus 1 equal to 0. If you compare with ay square plus by plus c equal to 0, then the value of a is 1, b is 1, c is 1. And the roots alpha beta is, you know this equation, minus b plus or minus under root b square minus 4ac divided by 2a. And using this equation you can find out the roots. What is b? Minus 1 plus or minus under root b square minus 4, a is 1, c is 1 divided by 2. So this is equal to minus 1 plus or minus under root of minus 3 divided by 2. Under root of minus 3 is the complex number, under root 3i, right? And so it has the complex roots. And so it has only two roots, y is equal to 0 and y is equal to 1. When y is equal to 0, since y equal to x square, x is equal to 0, since y is equal to x square, x is 1. So it has two intersection points. One is 0, 0 and another one is 1, 1. Right. Now, I think we are able to write down the limits for dy dx and dx dy. So let us try to write down the limits. How do we write the limits? Double integration f of xy dy dx. Double integration f of xy dx dy. First we write for dy dx, dy, so inner limit of y, and for the inner limit, what we do? We draw vertical line from bottom to upward direction. So let us draw. So whenever we draw the vertical lines, we are entering from this curve. Do you know the equation of this curve? Y equal to x square. So y equal to x square is our entry. We are moving ahead in the region and we exit from this curve. What is the equation of this curve? See, this is our exit. Exit has the equation x equal to y square. So our exit is x is equal to y square. I have to write the limit in terms of y. So what is y here is obvious, which is x square. What is y here? It is plus or minus under root x. As we discussed in the last example, we are in the first quadrant, so we choose positive value, so it is plus under root x. So my lower limit is x square and upper limit is under root x. Now the question arises, outer limit of x must be constant. How do we write the outer limit? We observe the region, how much portion of the x-axis is covered. So can you tell me how much portion is covered? This much portion. This. What is the value of x? X is 0. And what is the value of x? X is equal to 1. So I write The lower limit x is equal to 0, upper limit x is equal to 1. Now the second case for dx dy, so inner limit of x and outer limit of y. How do we write x? So we draw the horizontal line from left side to right side. So let us draw the horizontal line. We are entering in the region from this curve. This is our entry here. This is our entry in the region. X is equal to y square. So x equal to y square is my entry, and we moving towards the region and we exit. Now the exit. What is happening here at exit? The equation of the curve is this: y is equal to x square. So the exit is y is equal to x square. I have to write the limits for x. So what is x here? Y square. And what is x here? Plus or minus under root y. Since the region is in the first quadrant, we pick the positive value. So root y. My lower limit is x equal to y square. Upper limit is under root y. Outer limit y must be constant. How do we write y? How much portion of the y-axis is covered? So see, this portion of the y-axis is covered. So here the value of y is 0. Here the value of y is 1. Right. So lower limit is y equal to 0. Upper limit is y equal to 1. I hope the idea is clear. Let us move for more difficult regions. The region R, which is bounded by y is equal to x square and x plus y equal to 2. X plus y equal to 2. Okay, so first task is, as usual, draw the region. This is x, y, 0, x plus y equal to 2 is the line passing from 2 points. See, when x is equal to 0, what is y? Is 2. I say when y is equal to 0, then what is x? X is equal to 2. So the curve or the line is passing from these 2 points, 0, 2 and 2, 0. So say this is the point 2, 0 and this is the point 0, 2. Then the line is passing from these 2 points. Let me rescale the points. So this is the point 0, 2 and this is the point 2, 0. The line x plus y is equal to 2. What next? The curve y is equal to x square. The curve y is equal to x square is this. And this line will be continued to here. This is the curve y is equal to x square. So what is the region? Region is bounded by these two curves, the line and the curve. So this portion is our region. This is the only portion, right, which is bounded by the line and the curve. So the region R is this line and this curve. Now what is the first step? Whenever you draw the region, you must mention all possible intersection points. So let us find out the intersection points. We have given the curve y equal to x square and x plus y equal to 2. So what is y here? Y is equal to 2 minus x, which I substitute here. So I have x square is equal to 2 minus x, which gives me x square plus x minus 2 equal to 0. This is the quadratic equation. Which are the factors? The factors are, can anyone tell me which are the factors? The factors are x plus 2, x minus 1 equal to 0. So we have two values of x. X is equal to minus 2 and x is equal to 1. When x is equal to minus 2, what is y? Y is equal to x square. So this is equal to minus 2 square. Y is equal to 4. So when x is equal to minus 2, y is equal to 4 is the first intersection point. When x is equal to 1, what is y? X square. So this is 1 square. So y is equal to 1. Right. So x is equal to 1, then y is equal to 1. So these are two intersection points. X is 1, y is 1. X is equal to minus 2 and y is equal to 4. These are the intersection points. Now we are able to write the limits. Let us write the limits now. Double integration f of x y dy dx. What we do? Now this is repetition. We write for y. Clear? So let us draw the lines, vertical lines. We are entering from which curve? Y is equal to x square. So y is equal to x square is our entry. And exit from this curve. What is the exit? X plus y equal to 2. We are writing for y because inner limit of y. So y is equal to x square 2. What is y here? 2 minus x. So y is equal to 2 minus x. For x, what we have to do? Find out the portion of the x-axis which is covered by the region. So the portion of the x-axis from this to this. This is the portion of the x-axis. What is the value of x here? Minus 2 and the value of x here is 1. So x is equal to minus 2 becomes the lower limit. X is equal to 1 become the upper limit. Is this clear? Dy dx. Now let us write for dx dy. Double integration f of x y dx dy. Clear? Let us see what is happening here. Dx. So from left side to right side. This is the left side. We are entering to the region. From which curve we are entering? We are entering from the curve y is equal to x square. So our entry is y is equal to x square. This is our entry. Now let us exit from the region. So you observe, see, when we exit, then we are exiting from the line. So we are moving and we exit from the line x plus y equal to 2. Clear? But suppose few persons are very near to bottom of the region. See, very near to the bottom of the region. Then they are exiting from the same curve, this curve. So entry is this, exit is also the same curve, which is not the situation here. Entry is the curve, exit is the line. Entry is the curve, exit is the line. But from which point this situation occur? This point, point 1, 1. This is the point. This is the point from where the exit is changing. There is no change in the entry at all, but the exit. See, this is the exit up to this. Right. So the person who are moving till this level, they will exit from the line. But the person who is moving at this level, they will exit from the curve. Now entry becomes the lower limit, exit becomes the upper limit. Upper limit must be unique. That must not be more than one upper limit. So what we have to do? We divide this region into two parts. Right. Question is, how do we write? So this is region R. I am dividing this region into two parts, R1 union R2. See, from this intersection point, I am dividing my region into two parts. This is R1 and this is R2. So first we write the limits for R1 and then for R2. How do we write? That is also important. So which is equal to double integration f of xy dx dy. This is for region R1 plus double integration f of xy dx dy. This is for region R2. Now let us try to understand what is happening for R1. What is the portion R1? Now you know entry is common for both the curves, right? What is the entry? Y is equal to x square. That is the entry. Right. So I am writing for the region R1 and for the region R2. I am writing only entry and exit. For both the curves, the entry is y is equal to x square and y is equal to x square. We are moving towards into the region. Now in R1, this is the R1, we exit from the curve x plus y equal to 2. And here we are exiting from the same curve y is equal to x square. Clear? Don't worry. First thing is only identify the entry and exit. That we have already decided. Right? What is our task? Our task is to find which curve is my entry curve, which curve is my exit curve. The other thing we will check it. Right? For R1, inner limit of x. So I have to write 4x. For R1, what is x? X is equal to. So here x is equal to root y. Oh, y equal to x square. So what is x? Plus or minus under root y. So let me write y is equal to plus or minus under root y. X is equal to plus or minus under root y. In both the situation, our entry, you are entering in the region, that portion lies in the first quadrant or the second quadrant? That is in the second quadrant. And in the second quadrant, what is x? See, the second quadrant. This is. And our entry is this. In the second quadrant. So what is happening? In the second quadrant, x is negative. So I choose x is equal to minus under root y. X is equal to minus under root y. Right? So x is equal to minus under root y. X is equal to minus under root y is my lower limit. What is upper limit? Upper limit is exit. Curve are already fixed. For R1, it is x plus y equal to 2. For R2, it is y equal to x square. Right. So let us write for R1 first. What is x? 2 minus y. This is my x. X is equal to 2 minus y. So x is equal to 2 minus y for R1. For R2, the same situation again, y equal to x square. So what is x? Again the same thing, plus or minus under root y. But if you observe, our exit is this. Lies in which quadrant? Which quadrant is this? This is the first quadrant. And in the first quadrant, see, our exit is in the first quadrant. Right, and in the first quadrant, x is positive, y is positive. So I choose positive value, x is equal to under root y. So here, the upper limit x is equal to under root y. What we have to write now? Outer limit y must be constant. So let us write y for R1 and y for R2. Right. So what is y for R1? How much portion of the y-axis is covered from the region R1? R1 is this region, you know, this is the region R1. Right. R1, this region. See. How much portion of the y-axis is covered? So y-axis is this level to this level. So what is the value of y here? Y equal to 1. Here y is equal to 4. Clear? So y is equal to 1 to y is equal to 4 for region R1. Now region R2 is this. This is my region R2. How much portion of the y-axis is covered? This to this. So here y is equal to 0. Here y is equal to 1, which is my upper limit. Y is equal to 0 to y is equal to 1. So sometimes we need to divide the region into sub-regions. And I found this is the best exercise. The more examples. Okay, yes. One more thing. Let me give you one exercise. This exercise is of the same kind which we have already discussed. The region R is bounded by the curve y is equal to 2 under root x, y is equal to 4x minus 2, and the first quadrant. Right, this is exercise number 1. Exercise number 2, I am writing the same thing. 2 under root x is y, and y is equal to 4x minus 2. I am not writing first quadrant now. Clear? So you try with these two examples and tell me the limits. Write the limits in the comment. Don't forget it.